So histograms are used to organize and interpret data. Again, it's another picture. Not as user-friendly as a dot plot, I don't think, but that's my personal opinion. Histograms are often used with frequency tables to give a more visual view of the data. Each bar represents an interval. This might be a new word for you. An interval will have a number through a number. So which means if I had numbers like 1 through 5, in that interval you would find 4, you would find 3, you would find 1, you would find 2, you would find 5. Okay, so it's an interval, it's a span of numbers. The height of the bar indicates the frequency of the data. So if there were 10 of them, your bar would go up to 10. It's very similar to a bar graph. The difference between a bar graph, though, and a histogram, the bars must touch each other. If there is no data, then the interval is left empty, or blank, or alone, but there's nothing there. You don't put something there because of the statement that says the bars have to touch each other. If there isn't anything there, you don't draw a bar. Okay, so this is just a little bit of vocabulary. This is a frequency table, in case you forgot from yesterday. This is an example of what a histogram looks like. Notice the bars are touching each other. And then oftentimes you are asked to describe the shape of a histogram. And how you find the shape is you actually trace the bars. So if this one, I would go up and go down. Kind of looks like a mountain, so sometimes you can call it a mountainous shape. That's okay. A normal shape is also acceptable. Another one you could use here would be symmetrical. So let's put a couple of those vocabulary words there. Symmetrical, mountain, or normal. So 3 different ways you can describe that shape. Means it's kind of equal, like if I put a dashed line down there, most of the data on the left and most of the data on the right, they kind of match each other. Go up and then back down. Now a right skewed distribution, when I trace it, it slopes to the right. So most of the data is on the left and slopes to the right. That is called right skewed. Now I left the left skewed blank because years ago I couldn't find a picture for that one. So this is kind of the opposite of a right skewed. That means it's going to slope left. So I've got my slope, and then my data is to the right. So it slopes, and you can fit this in your space. Slopes left, and you have your data on the right. And in order to find out how the data is distributed, you have to trace the histogram. So we're going to practice with determining this shape. So here I am, I'm tracing, 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 and it's going to slope. It slopes to the right. Most of the data is on the left. What would we call this? Right skewed. So this histogram would be right skewed.